Hey guys, Joe Pye here at Advanced Innovations. Welcome back. Well, as promised to one of my viewers, when that What Were They video saw 10,000 views, I posted a solution. So this is a spoiler for anybody that has not watched that other video. You know, if you're not interested in testing your own brains and creativity for a while, then you might want to shut this one down now and go back and watch that one and see if you're right at the end of this video. I'm going to start off with a couple of shout outs like I usually do, and this one is long overdue. It's going out to a Mr. Eric Cortina. Eric was very instrumental and helpful in the documentation and some models and some drawings on the AR lower series I did a while back. And I reviewed that the other day, and I noticed that in the credits at the end, I didn't give him a shout out or a credit or a thank you. So Eric, thank you very much. And that is spelled with a K, E-R-I-K. He's a precision shooter, and he's big into reloading, and I believe he represented Team USA for a while. So if you're a shooter, go see Eric Cortina's channel. And Eric, if you're watching, thanks, bud. I'm really sorry I skipped over you. As far as the solutions to the what are they, Tanda Madison, if I'm saying that wrong, forgive me. She got, I have to say that she was right there. She was so close with one of her guesses that I just wanted to slap myself in the forehead and go, you're so close. All right, we're going to walk out. I'm going to show you some of the suggested applications for those tools, and it was very creative and very common. As a matter of fact, there was quite a few of you that thought it was going to be used for the same thing. Now, whether or not it can be used for that, the intended use is what I was looking for. So let's take a walk out. I will show you some of the suggestions that were made, and I will pop the lid off of exactly what those were intended for. Let's take a walk. This has undoubtedly got to be the top comment as far as the application of this tool is concerned. With the bar trapped between two centers and an indicator positioned as such, with the contact tip at the center of the material, or as close as you can get it. By sweeping the indicator back and forth, you can check the alignment of your tailstock to your spindle center. That is the top comment as far as what this tool was intended for. So yes, the tool can be used for it. Is this the intended application? It is not, because these brass bushings right here, they have no purpose in this particular setup, and they are not explained. So if you guessed that, good. Yes, it can be used for that. No, that is not the intended use. Let's take a look at another application that was suggested. Another very popular comment in regards to what the tool is for was to take one of these brass bushings and drop it down into the center of the rotary table. Now, unfortunately, the center of my rotary table is much larger than this bushing. It is also tapered, so this would not fall in there. But if this were a straight bore and this seated in there nicely, then with the application or the insertion of the second bushing in the collet to allow this rod to float back and forth, when the spindle was located over the center bore and this rod dropped down and made the transition between the two bushings smooth, you would have an alignment between the quill, the spindle of the mill, and the rotational axis of the table. Would that work? I could see that it would work, yeah. Would it be incredibly precision? It would be as precision as the bushings were machined and as the fit was from the rod to the bushing. But other than that, I would suggest using an indicator instead. Is that the intended use of this? It is not. One more time, let's check another option. Well, there were only a couple of comments that suggested actually putting the rod in a collet. And I got to tell you that you are really close when you get to this point. Once you've established that the table is true to the world, true to the spindle, you know the diameter of the rod, and you can move the rod offset to establish a hard stop, or at least a temporary bumper to push your material up against. And you know that once this edge starts to migrate away from center, that's the size of the radius that you will ultimately get. If you've set your table up with a rail like I have here, you can use an edge finder to go from the center of your table over to your rail. You know what this gap is, and you can adjust accordingly to get a true tangent arc on two surfaces. Is that a good application for this? That's an outstanding application for this. It is, however, not the intended application for this. Now, this is, we're going to get on Tanda Madison's suggestion right now, and I got to tell you, I was impressed, but man, you were so close. So close. Actually, very close, and I might actually steal your idea, so way to go, Tanda. We're going to show you what's going on here in a second. Let me put this on a tripod and we'll get going. Now this particular suggestion is the one that I thought was the closest to being correct. Actually, they're all correct if they work, but this would be the closest to the one that I was going to say is the intended use for this. With the blank in the collet, knowing the offset from the collet and knowing the diameter of these bushings, put the bushing over the rod, make your offset. Bring the rod down, clamp the bushing, make some type of adjustment, rotary, linear, it doesn't matter. Do the exact same thing again. Bring the rod down, fix the bushing. What does that do for you? That would then establish 2 points of tangency if you had an arc component or a round component or a piece with an arc on it. Once you bumped it up against those two bumpers with the correct offset, of course, let's just illustrate that a little bit better for scale. Those bumpers would automatically give you the center of rotation. That was Tanda's suggestion. I think that's a fantastic suggestion. And if these had little feet on them that you could put a screw or something in one of the T-slots and use them as a radial bumper, that is a fantastic idea. So thumbs up on that one. This is the intended use for the tool. And although this is being demonstrated in a vise, it is perfectly fine if you were to do this in your turntable if you could. Now this is not necessarily the first feature on the part. It could be one other feature on the part or any other feature on the part. But the best use for this is when you have a round or a bore that you're not allowed to have a hole in, you're not allowed to have a center point of, and there's really no way to locate from the outside easily. This is the suggestion. Take a piece of cardboard, I'm going to put it on my part. I'm going to bring down my rod on location to the feature that I want to cut at a later date. I got a lot of comments and a lot of questions about, okay, fine, setting up with a center is fine if you have a hole, but what if you don't have a hole? Well, that's what this is for. Take it away. I am putting a piece of double stick tape right directly under that target. This is incredibly high strength industrial type tape, which is not going to yield. This is when you take the bushing, put the bushing on your rod. Bring the rod down. Because the cardboard was there initially, it is not going to interfere with the tape. Drop the bushing. This is now rock solid. That is not going anywhere. When you transition over to the rotary table, you can repeat this process if you're gentle. And at the very least, you have an ID and an OD true to the location of the center of rotation of the feature that you want to put on there. The reason that there's multiples is if you have it in a setup where you can track the center point of your next feature or your other features, you can put them down at the same time. Make sure that the bushing that you use is smaller than the radius that you're going to cut. And if you care to knock this off before you start to cut, well, that's fine too. That is the intended use. Let's put it over on the rotary table for a quick, yes, it works demo, and move on to the next one. Once the bushing is secure, move it over to the rotary table. Bring the rod down. This is strictly to get it close. Put the rod back in the hole. You now have a rotation ability. And all you need to do is get the plate true to the table. You need this gap true to the rail. You can't indicate it. Spindle's being used. Adjustable parallel. Wonderful little tool. Stick it in there and squeeze it. Let's watch the gap. you go. As you squeeze it, it will establish this edge true to your rail, concentric. Now I strongly recommend, if this is a precision feature, that you pull this rod out of here and you check with an indicator the inside or the outside of this collar. And I would have to say, without too much pressure on this, I don't know how much this is going to flex. Let's line this up. Just for yucks, let's pop an indicator in there and see exactly how close that is. Okay, that is -3.5. -5. -5. About -2.5. So that would tell me that I pushed it a little harder than I should in that direction. And it needs to come back this way. Well, that is not a problem. You bump it. There you go. These little brass bushings are intended to be targets for non-trackable features, and you can use as many of them as you want. You can use them inline if you want to use 2 of them inline to establish linear at an angle, whatever. You can get very creative with them. And Tonda, thank you very much for your suggestions and your comments, and you were very close. And I would say that you were probably as close as you can get without being spot on. So thank you very much, guys. Let's take a look at the second one, and you're going to like this second one. It works probably better than this one. Without a doubt, the most popular answer for this particular tool is right here. Put it in a collet. Since this block is on the center of this pin right here, this plane is midpoint and will be the midpoint of any spindle that you put it in. As far as setting the height of a tool in your lathe, you would have to indicate this flat in order for this to be a true reference surface for any tool. If it were, now that's extreme, but if it's high or low, depending on what side of the block you used to reference your tool, your height would be considerably different than what you had anticipated. So can it work for this application? Yes, it can. Is it conditional? It is conditional based on this being indicated flat. So can you use it? Yes, you can. Intended use? Not yet. I'll show you another one. Okay, anybody that has ever worked in a wood shop has probably seen the vices that mount to the side of a workbench, where it just has one jaw that slides out from the workbench surface, and you say, okay, well, what good is that? Somewhere along the line, you're going to see a series of holes in that bench where you drop in a thing like this. I believe they call it a bench dog. You just drop it in the hole and it stops at the tabletop, and it becomes the stationary side of the vise on your workbench. If you've never seen it, it's a pretty cool setup. Very popular in woodworking. I would say not so much in metalworking. Could it be used for that? Absolutely. But that's not the intended use. Good guess, though. Let's move over to the mill. Another very popular suggestion for the use of this thing is to drop it down into the taper of the turntable and form a hard vertical surface that is on line with the center of the table. I think that's a fantastic idea, but like I said before in other videos possibly, mine is a taper. If this had a taper on it, or possibly a taper plug with a sleeve in it that you could use around, that would be a fantastic thing to do. So yes, but you would be limited to offsetting your part either on center or away from center, depending on how you did it. So is that the intended application? No, it's not, but I think it's a very good suggestion. Okay, let's move on. Another very useful application for this tool is to squeeze it in a vise this way. By indicating the cylindrical object, you know that you are exactly over the back edge of this jaw, And if you know how wide this is, and this base is exactly 1 inch wide, I know that I'm exactly, I like to use that word exactly. There is no exactly, but theoretically 500 from this stop right here. So after I track my 0, scoot over 500, and you are right on the corner of that stop in the back jaw. This is a very good application for this particular tool, yet it is not the intended application. Let's look at one more. The intended use for this particular device is for setting up material on your turntable. There is no doubt about it. It is an edge finder, but it is I can't call it an expandable edge finder. It's more of an adjustable or a preset type edge finder. This is 500 thick, it's 1 inch wide, and it's exactly on center with this 3/4 rod. So when this is aligned with the back jaw of your vise, you'll know that the back jaw of your vise is exactly on center with the spindle of your machine. When this back side is aligned with your vise, it's exactly 500. Okay, so you say big deal, right? You have 0 or 500? Actually not. Let's take a look. Now the intended use for this particular object is as such. With the center line cutout facing the stationary jaw, bring it down into the area of the vise. This vise is on a rotary table and it is not secured to the table at this time. It's loose. It's floating around. Bring the jig down into the vise and lock the quill. Now I'm going to purposely leave it off the back jaw, so as I tighten up, I'm tightening down the movable jaw right now. As I tighten it up, you can see the back jaw coming into center line. Okay, boom, we're on center. This is where you would bring your stop in from the other side and bump the block. The block is exactly 500 from the center line. So for setup purposes, this vise is now exactly on center with the rotary table. I'm going to pull this out and go handheld here for a second. What you want to do is align it to your stationary rail or tram the side somehow. And I do that with an adjustable parallel. Stick it in here. As you squeeze it, watch the vise. Boom. Now you're in. This is the point where you would take your stop, bump your stop against your part, lock it, lock the vise down to the rotary table, clamp it, toe clamp it, whatever. When you unlock it and raise the quill, you now have a setup that has a rear face exactly on center with the machine, and this stop is 500 from this surface. Okay, what does that do for you? Well, if you have a 500 gauge block, you can now establish any size you want for a radius on that. Let's go back to here, take it to another level. Now I'm going to knock the pin out of this vise for a second, and I probably won't put it back on because there's no sense in demonstrating how to do it twice. If you want to set a specific radius, a very specific radius, you know that the stationary side of your vise has to be offset that far if you're going to put a part in this vise for a round. Now, whatever that round is, bring your stop back down within the boundaries of the jaws. Gauge blocks right there. Next time I'm going to get magnetic gauge blocks. That'll be great, right? Let's do that. Put the gauge blocks between the stop and the part. Excuse me, between the stop and the vise. And do the exact same thing you just did. Tighten up on the gauge blocks. Now the stationary side of your vise is now exactly the offset radius that you need to the center line of your spindle. Once you know this, you can then return the spindle to the outside with your y-axis or x-axis dial, and when you turn your chamfer, or excuse me, when you turn your radial feature, you'll get the desired radius based on the diameter of your cutter. The fact that you can put gauge blocks in here is one of the unique features of this, but the big setup idea is not to align the chuck to the spindle with the vise already tightened down. You need to let the vise center itself on the spindle and then tighten the vise down to the table. The sequence of events here is what makes this thing work so well. Alright, gauge blocks in the back will be set to the radius that you're going to need. That will keep the part inbound, and when you move the cutter to the outside, you have the radius that you're looking for every time. Just to help clarify the side setup, since the back is so intuitive, with the side being 500 out, let's take a look at how you would adjust your stop 500 in without having much difficulty. After the vise is secure, which is what you want to do after your radius is set, remove the plug. I'm going to use a 1, 2, 3 block for this demonstration. If you were to bump the 1, 2, 3 block up against it right now, you'd have a 0 across the back and 500 in. So your center would be back here on the back edge. Take a 500 gauge block and pinch a 500 gauge block against your stop. When you close the vise, remove the block, move the stop in, lock it down. You are now 0, 0. Zero and 0 in the back. Okay, perfect. That's the basics. You can manipulate these stops however you see fit. If you want to zero it out this way, add gauge blocks for the offset. You can come up with a variety of different radiuses to suit your need. And when combined with little brass plugs, and I think you might have just seen how to use those, there's not much you can't do on a turntable. Wait till I get into the subplates and the fixture plates that are pin driven. You're really going to like that. Well, thanks for watching, guys. That's all I got for you. And I tell you, if you got one of these in your toolbox, rotary table work is a breeze. Good luck. Well, I want to thank everybody for the comments that they left, the guesses that they took, and just for the views that they racked up, the 10,000 views in a couple of days. I was impressed by that. So thank you very much for sticking around and playing along. I will do that again. Once in a while I'm going to come across something in my box that I think may be unique to my box, and maybe not, who knows. Anyway, thank you very much for watching. Joe Pye, Advanced Innovations, Austin, Texas. I'm out.